digital media, electronic media, and journalism and mass communication program. And all these 4 programs are available in distance mode. 2 programs are available in online mode, development communication and digital media.
Hello and welcome to the session. In today's session, we'll be discussing about multi-valued dependencies and how multi-valued dependencies can be used to derive fourth normal form. But just a brief recap, like where exactly we come to multi-valued dependency. Well, the first dependency which is available in a database management system is functional dependency. So let's look into the properties. Single valued dependency or functional dependency determines the dependence of a set of attribute on the other. For example, employee number will uniquely determine the employee name and department, and it can be represented as employee number functionally determining employee name and employee department attribute. And these types of functional dependencies were used to derive different forms of normalizations like first normal form, second normal form, third normal form, and BCNF. And the purpose was removing different types of single valued dependencies which were there. If there are different types of dependencies like transitive dependency or dependency on the non-key attribute of those kinds of things were actually removed, and lot many problems, that is update anomaly, etc. were update anomaly, insertion anomaly and deletion anomalies were removed from a database system. So it is very, very important that we need to know, is there any other kind of dependency which exists beyond this particular kind of dependency? So the question once again we are trying to answer is, does relational databases has other types of dependency? And the answer is yes. 2 such dependencies are multi-valued dependency and joint dependency. And in addition, there are more dependencies, but we won't be discussing about them. These dependencies cause, once again, the problems like update anomaly, insertion anomaly, and deletion anomaly in a relation. So we will study these anomalies in the context of the multi-valued dependency only, because more normal forms have been designed based on these dependencies, but our session we will be focusing only on multi-valued dependency and fourth normal form. So with this context, now let us try to focus on what multi-valued dependency would mean, right? So let us try to understand what multi-valued dependency or how we can define it. So consider a relation, okay, employee, okay, and the name of the relation is EMP, and there are just 3 attributes: employee number, project which this particular employee is working on, and the tools with which this particular employee is comfortable with. And the basic constraints in on this relation are that an employee can work on several projects. So basically multi-valued, that is what is important here. That is one employee, multiple projects. In functional dependency, if had it been a functional dependency, a particular employee whose number is, let's say, 1 will work only on one project. But in multi-valued dependency, the first constraint is that this particular constraint on single unit is removed. Okay, so an employee can work on multiple projects, more than one projects, and he or she can work on more than one tools also. Okay, so an employee has skills in several tools. So that is another, these are the constraints in a sense that the basic idea, constraint has been removed, that is single value dependence. And there is no functional dependency in this particular relation. So third is, there is no functional dependency because for a particular employee there will be several projects. For a particular employee there may be several tools on which he or she can work with. This relation has two multi-valued attributes. So these two are project as well as tools are multi-valued attributes, and both these attributes are independent of each other, in the sense that project is not dependent on the tool. Normally this may be cases in some database design, but in this particular case we are assuming that they are independent of each other. Both the attributes are independent of each other, and employee can work on any project and can use any of the tool. So with this particular thing we try to see. So let's look into a typical sample data, how we are going to represent when this multiple dependency or multi-value attributes are there in a database system. So let's take an example of that. For example, the employee relation. So employee 001, now he or she works on DBMS. His projects are DBMS project and e-commerce project. So there are two projects which are going on where he or she is working. And his tools are basically Python and virtualization. So he or she is good in these two tools. Employee 2 happens to be working on e-commerce and data automation project, and projects which he or she is tools he or she is comfortable is PostgreSQL and virtualization. And third one is working on just one project, but that is just by chance, and PostgreSQL is the tool which he or she is comfortable in. Now the very first question comes here is how we are going to represent this as a relation, because in a relation only one value is allowed in an attribute. You can't represent two values in an attribute. So it is to be represented with the help of a relation. Okay, so how we can represent it as a relation? Well, the 1NF of this particular situation is going to be very tricky. And look here, employee number, project and tool. So employee 1 works on DBMS project, all right. Okay, he or she works on Python. So DBMS project, Python. DBMS project, virtualization, because both are independent. So both the information need to be told, right? That in E1 has expertise in tool Python as well as virtualization, and he or she is working on DBMS project. Because suppose we drop him from e-commerce project, then only this place we will come to know that he or she can work on Python or virtualization project. Right. So both the cases are to be told for both the projects. Now that makes it slightly more difficult. So suppose a particular person have 3 projects to work on and 4 specialization, then there will be around 12 tuples representing that particular information. Here he was this particular person is working on 2 projects and and having 2 specializations or 2 tools where he is specialized on. Then we have 2 into 2, 4 tuples which are representing that particular thing. The second thing is, okay, same is the case with E002. There was 2 into 2, so you can see there are 4 tuples for E02 as well, and 3 was working only on one project and was specialized in only on one particular tool. So just 1 tuple is representing that particular information. Now, interesting part to here to notice, what is the key of this particular relation? Well, key to this particular 1NF relation is going to be employee number, project and tool put together. You can see that E001 and DBMS, this cannot be the primary key, right? So all these three put together as single, the composite attribute, that is employee number, project and tool together forms the primary key. Are there any functional dependencies here? All three are part of the primary key, right? So there cannot be any functional dependency. Okay, so once there is no functional dependency, this particular 1NF relation technically is in second NF, third NF and BCNF also. However, does this particular relation suffer from anomalies? Well, that is the question which we have to answer now. Does this table has update, insertion and deletion anomaly? The answer to this particular question is very much yes. So what is the update anomaly? Obviously there is duplicacy of information that E001 is working on e-commerce project. And suppose the name of this particular project is changed to M-commerce. Then there is a chance, suppose we are not able to update all the instances, then we will be having problem with this particular, that is the update, that is redundancy leading to update anomaly. So consistently all informations are to be updated, which is sometimes not possible in certain database systems. Then insertion anomaly. Suppose a particular person has been employed, a new person has been employed, let's say his employee code is E004 and he has not yet been assigned a project, yet he knows tools like Python, virtualization and PostgreSQL, all the three, suppose. Then in that particular case, we cannot enter that particular information. Why? Because project is part of the primary key, right? And you do not have a null value for the part of primary key. So you cannot insert that particular information here. So there is an insertion anomaly in this particular table. Now there is also a deletion anomaly. Deletion anomaly in the sense, suppose this particular E003 is withdrawn from bank automation project. Then the information that E003 knows the tool PostgreSQL, right, that is going to be also deleted because it will, we might have to delete the entire record. Okay, and only one instance of such record exists, so this information will be lost, and that is the typical case of deletion anomaly. So what we can see, this particular relation is in 3NF, BCNF, yet this relation has update, insertion and deletion anomalies with which we start the process of normalization, right? So there are some problems with this particular table. So what we are basically trying to answer, is it a normalized relation? All the attributes are key attributes and no overlapping candidate keys, right? So this is a normalized relation. The concept of multi-valued dependency relates to relation that contain more than one multi-valued attribute. So this is a particular case, right? So this example is a typical case where we have multiple valued attributes, more than one. If it is one, then we can deal with that particular situation. Okay, but here we have more than one such attributes, and that is what is going to lead us to some problem situation, and all sorts of anomalies are there in a relation of this particular form. So let's look into the definition of multi-valued dependency. Now consider a relation where x, y and z are a set of attributes and multiple associated one or more values of attributes y depends only on value of attribute x. So y is multiple associated with x. So there are multiple instances of y in respect of x. Okay, and so is the case with the z. So further, value of attribute y has no dependence on the value of attribute of set z. So if MVD x to y right, holds in R, another MVD X to Z would also hold. So they exist in pair. Okay, that's why you require at least 3 attributes. Okay, as the function of attribute set X and attribute set Z are symmetrical. Both are symmetrical in nature. So, example what you can see in this particular case, employee number can determine all the projects on which employee is working on. So, multiple dependents. Employee number can determine all the attribute tools in which that employee is skillful. So, there is both the project and tool attributes are independent of each other. So this third condition is also very, very important. Okay. Therefore, the MVDs which hold in this particular relation are employee number multi-determines project, employee number multi-determines tool. Right. Now, this is the situation. Okay. So we have come to a situation. We have identified the problem. Problems are update, insertion and deletion anomalies. And now we know that there exists 2 MVDs in this particular relation, right? So this example relationship we have already discussed. So let's try to define the another formal definition of MVD. For a relation XYZ having a multi-valued set of attributes, okay, Y associate with it with value of X, assume that attributes Y and Z are independent and Z is also multi-valued. This we have already stated, right? Okay, X to Y is set to hold on R XYZ if 2 tuples T1 and T2 in R that agree on some value of X, T1X equals to T2X, then R also contain 2 more tuples T3 and T4 not necessarily distinct such that T1X equals to T2X equals to T3X equals to T4X and T3 agrees on T3 and T1 agrees on Y, T3 and T2 agree on Z and in T4, T2 agrees once again on Y and T4, T1 agrees on Z. This definition becomes completely confusing. So this example solves this particular issue. So you have a tuple where employee 1, actually what basically it says, this particular MVD says that we got to have 4 tuples when we have 2 cross 2 tools, right? 2 cross 3, 6 tuples. So this is something like, so we had, suppose we have tuple that employee 1 is working on project DBMS as well as e-commerce, and he is working on, he's skilled in Python and virtualization. Then there will 2 more tuples will be existing such that this Python will go to the next project and this virtualization will go to DBMS. So this cross, which we had shown in the example relation, should exist. Then only. So all 4 tuples must exist if there are 2 cross 2 kind of a situation. 2 cross 3, all 6 tuples must exist. This is what is the value of MVD. If they exist in a relation, then only we say that the MVD holds in a relation. So what are the conditions for MVD? Let's try to recap this condition. Every value of Y appears with every value of Z to keep the relation instances consistent. Y and Z are determined by X alone. There is no relationship between Y and Z. This we have stated many a times. Independent, both of them are independent. Since Y and Z appear in every possible pair and hence their pairing present no information and are of no significance. So we are basically representing the information in 4 tuples, but actually we are wasting a lot of space. Okay. Only if some of these pairings were not present, there would be more some significance in the pairing. This happens, suppose one of them had been missing, then this particular concept of MVD is not going to exist at all, right? So therefore this particular situation. And finally, you may note if Z is single valued and functionally dependent on X, then Z1 equals to Z2. Okay, this kind of a situation occurs when we are dealing with functionally independent string. Now, finally, before we move to the next slide or normalization, we must define another thing which is called trivial MVD. So MVD X multi-determines Y is called trivial MVD if either Y is a subset of X, okay, so Y is just a subset of X, or X and Y together forms the relation R. Okay, so there is the MVD is trivial since it results in no constraint being placed on the relation. So this particular thing, example is, suppose there is a relation called dependent with employee number and employee dependent number. Okay, so an employee can have 0 or more dependents. So employee 1 can have dependent number 1, dependent number 2, or he or she can have even 0 of dependents. Therefore, employee number uniquely determines the value of dependent numbers. However, this MVD is trivial as employee number and employee dependent number together forms the relation dependent. So this is basically the key is this, and there is no there is no update anomaly, insertion anomaly, or deletion anomaly is in this particular relation, because employee number is uniquely determining the dependent number, dependent ID. That's it. Okay, so the dependent relation cannot be decomposed any further. So wherever we have just two attributes, and with the and that is a multi-valued attribute, we have absolutely no problem. Therefore, a relation having non-trivial MVD must have at least 3 attributes. That's what we have stated earlier, and 2 of them would be multi-valued and non-dependent on each other. So this we had been repeating for a very long time, that they should not be dependent and both have to be multi-valued. Both should be dependent only on the primary key, although they are multi-valued. So what do we do with this particular MVD? How do we remove the update, deletion and insertion anomalies? Well, so what we do, we define the 4th normal form. So the definition of 4th normal form is a relation R is in 4th normal form if for all the multi-valued dependency X of the form X multi-determines Y, any one of the following clause holds. The multi-valued dependency X to Y is trivial, okay, or X is a candidate key of R. So if any of these condition holds, then the situation is going to be like that. So dependency X determines phi or X determines Y is a relation is trivial since they hold all instances of R X comma Y, and R X Y is considered to be 4 normal form. The definitions are always difficult. So definitions are to be supported by example. So what do we do? Okay, so this is a simple example. So suppose if R has 3 attributes with only 3 attributes and trivial MVDs A, B to C, this is in 4NF. Okay, if a relation has more than one multi attribute, you should decompose it into 4th normal form using decomposition. For example, RXYZ, if there are 2 MVDs existing, okay, then decompose the relation into XY, R1 as XY and R2 as YZ. And in both the relations now, one MVD will hold. X to Y will be in this relation and X to Z will be in this particular relation. Remember, X intersection Y has to be null. The set of attributes Y and X and Y are disjoint, that is the prior condition. Then R must be decomposed to XY as well as XZ. So where Z represents all attributes other than those in X and Y. So this is how the decomposition takes place. But this is not a good example to deal with. Okay, so the good example, okay, so a good relation, what we say, a relation is in 4th normal form if all functional dependencies are a result of the keys. When multi-valued dependencies exist, a relation should not contain 2 or more independent multi-valued attribute. Okay, so let's do the actual decomposition. So this all the theory which we have talked about should become clear. The decomposition results in reduction of redundancy and avoidance of anomalies. Okay, so now our example was we had employee number, project and tools. Okay, and the MVDs were employee number determines project, employee number determines tool. And what our statement says, both are independent of each other, right? Employee number and union project are null set, right? So what we can do, we can break this particular relation based on these two MVDs into two relations, right? So the relation has no FD but two MVDs, therefore the relation is in BCNF but not 4NF. The decomposed relation into 4NF, you may use any of the MVD to do that, and the decomposed relation happens to be employee number and project with MVD employee number to project, which is a trivial MVD in this relation, and the employee number and tool with the MVD employee number, which is once again a trivial MVD. Now how this particular decomposition will look like? Okay, well, this was our original relation, if you remember in the slide, right? So this is our original relation, and after the decomposition, what it happens or what it becomes, we have decomposed into two relations, employee project and employee tool, right? So the key to the relation, okay, we'll talk about key, but before that, so this employee project relation will have employee number and project. And note the thing, employee 1 is working on DBMS and e-commerce project. So these two things are here, appearing here. Employee 2 is working on e-commerce and bank automation project, perfectly working over here. Okay, and employee 3 is working on bank automation. And employee tool, what you once again see, the tool he is comfortable is Python and virtualization, and she is comfortable in PostgreSQL and virtualization, and E3 in PostgreSQL. Now if you join these two tables, you will get the original table which we have shown. Okay, so you can always check this particular thing. Now the key to the relation employee, this particular relation, it's going to be both the attribute put together, because still it's a trivial MVD, right? So the employee number and project is going to be the key, the combined composite primary key. And for employee tool relation, we have employee number and tools. And there is no redundancy in employee project and employee tool relations. You can check it. No redundancy, no MVD, nothing. So this is free of all the anomalies. Both the relation do not suffer from any anomaly. So this is what is the basic thing. That is what we wanted. So we first identified the concept of MVD, right? So what we have done, we have checked for MVDs. Try to find out if there is MVD which is existing there or not. When MVD can exist, when there are at least more than two attributes which are derived as multi-value attributes, and they are in the same relation and only dependent on the other one attribute over there, right? So when you have multi-valued attribute, the only thing you can do to do the best is normalize into 4NF. And the idea is simple decomposition. Decomposition, how do you do decomposition? Simply by breaking the relation into trivial MVDs into two separate relations, and it will be free of all the anomalies. With this, we end this particular session. Thanks for being with us.